Welcome, let's solve xy prime plus 2y equals x plus 2. So first we're going to divide each term by x. You're going to have y prime, the x divides away. Then you're going to have 2y over x. If you like, you can write it this way, so 2 over xy, and stop for a second, make a key observation here. This quantity 2 over x, this is d and e at x equals 0, because 2 divided by 0 is not defined. You have to keep that in mind. And then x divided by x is 1, and then 2 divided by x is just that, 2 over x. So divide each term by x. Then you can identify the integrating factors. So mu of x is e raised to this antiderivative of 2 over x dx, the coefficient function here, and then you go through that. So e raised to 2 ln of the absolute value of x, antiderivative of x in the bottom is ln x, which is then e raised to the ln of the absolute value of x squared. And then lastly here, well, by the rules of logs, e and ln are inverse functions. You can cancel them off, and all you have left over is absolute value of x, but that's just x squared. Doesn't matter what x is. If you first take its absolute value and you square it, it's the same as just squaring it in the first place. That's all, because squaring gets rid of negatives. Now multiply each term by x squared. Therefore, you will have each term of this equation right here, okay, to be clear. So you're going to have y prime and then x squared. Okay, then you go on. So x squared times 2 over x means that x cancels, which means you're left only with 2xy. And then on the right side, you will have 1 times x squared, which is x squared, and then x squared times 2x, so x cancels. You're going to have 2x this way, plus 2x. Now on the left side, the expression that you see is the result of doing the product rule on the following: x squared y and then prime. You can check it. So when you differentiate y, you get y prime, copy x squared, you add to it. The derivative of x squared is 2x, and then you copy the y. On the right side, you still have x squared plus 2x. Now you anti-differentiate both sides. When you do that, the prime goes away, leaving x squared y. The antiderivative of x squared is going to be 1/3 of x cubed by the power rule plus x squared plus c. Then you divide each term by x squared to isolate y. So y, the following: 1/3 x cubed divided by x squared is x. X squared divided by x squared is 1. And again, when I say divided by, you have to keep that in mind, right? That's valid except when x is 0. Anyway, and then you have c divided by x squared, so like this, c over x squared. And now we stop for a second. This is our general solution. It contains c, so this represents every possible solution depending on the value of c. So can we solve something like this? Y of 0 equals 1. Can we solve that? Well, we try it. So 1 is equal to 1/3 times 0. That's no problem, the first term. 1/3 times 0 is 0, plus 1, no problem. But then you have c over 0 squared. This term, this is d and e, doesn't exist. You see, that's not allowed. So y of 0 equals 1, apparently. Let's try y of -3 equals 0. Can we solve that? Well, so 0, in other words, is your y. And on the right side, you have to replace x with -3. So 1/3 of -3 is -1, like this. And then plus 1. And then you would have plus c over, let's see, that would be the value of x, which is -3 squared, as shown right here. Okay, hold on. Let me just move this stuff around a little bit in a second. Okay, so I'll do that down below here. Here we are. Now, just solve this for c if possible in some way. So everything goes away, and the only value that remains is the following. 0 is equal to c over 9. -1 plus 1 is 0, but that's like when you cross multiply, c is equal to 0. So this does have a solution. Y of -3 equals 0. It's y equals 1/3 x plus 1, because c is 0 in that case. So in this case, we have 1/3 x plus 1. As you can see, no problem. That seems to work perfectly, right? So let's see. When the -3 goes in, 0 comes out. We go right through that point. Perfect. Okay. Try some other ones. Just make them up, for example. So let's say we want 1/3 x plus 1, and just set c equal to a random value like 1 over x squared. In this case, look what happens. In this case, you get a vertical asymptote. Try some other value. So 1/3 x plus 1 minus 1 over x squared. So that gives you, as you can see, the two red curves. They also have a vertical asymptote. So these are some of the possibilities to be considered. You could say essentially the following, that in the case of this solution, where y equals 1/3 x plus 1, this is valid a negative through positive infinity this way. Some of these other ones are definitely not valid there. So like if you have a solution going through this point right here, okay, through this point right there, well, that's valid only from 0 to positive infinity. Okay, you can write it down, 0 to positive infinity for that solution that goes through that point. If you want, for example, a piece of the solution, say going through this point right here, that's valid only on negative through infinity through 0 because of the vertical asymptote. Whereas the black curve is valid on negative through positive infinity. So these are some of the major cases to consider when you are doing solutions to differential equations. Please be sure to leave a like, subscribe, thanks.